I'm going to spend a little bit of time showing you how to put these gas laws into mathematical problems. And so what you'll notice is that I give you the law, its definition, and then the formula. So P stands for pressure, and this goes for all of these laws. V stands for volume, and then we'll come across T as well, and T stands for temperature. Then you'll notice these little subscripts like a 1 after it, and that the 1 indicates the starting, and 2 will indicate the final. So let's look at the first Boyle's Law problem. So if 20.51 liters of nitrogen at 750 millimeters mercury are compressed to 23 millimeters of mercury at a constant temperature, what is the new volume? So what I like to do is list our variables from the formula. So we have P1, V1, and a P2 and a V2 along the left-hand side, and fill in what we're given with the problem. So we're starting with 20.51 liters of nitrogen. Liters indicates that it's a volume. And then we have 750 millimeters of mercury. Millimeters of mercury is a unit for pressure. And so we can plug that into our starting pressure. And then that pressure, or those gas particles, are getting compressed, so that means they're getting squeezed, and now we're down to 723 millimeters of mercury for our final pressure, and we need to calculate our final volume. So then kind of my next step is to write out the formula. P1 V1 equals P2 V2. And then plug in what we know from our equation, from our list to the left. So we know our initial pressure is 750, and our first volume is 20.51. That will equal our second pressure, which we figured was 723, and we don't know our second volume. So now it's just a little bit of algebra. Multiply out this left side, and go ahead, use your calculators, and you'll get that to be 1,537.5, and that's going to equal 723 V2. Need to get that V2 by itself, so we'll have to divide each side by 723. And when we do that, we'll get our second volume to equal 21.266 liters. The rest of the Boyle's Laws problems up through question number 4 are very similar. Your variable that you could be solving for will change, obviously. It won't always be V2. And that just messes with how you do your algebra, but they're all set up exactly this way. So our second type of problems here are for Charles' Law. And so, again, I like to write our possible variables along the left-hand side. Helps keep these problems organized. Then go ahead and read the problem. Calculate the decrease in temperature when 4.98 liters at 20.5 degrees Celsius is compressed to 2.69 liters. So liters, again, is indicating a volume, and degrees Celsius is indicating our temperature. So then we just have to figure out that we're starting with the 4.98 liters, and our starting temperature is 20.5 degrees Celsius, and our final volume is 2.69 liters, and we're looking to solve for our second temperature. So then rewrite the equation. T1 or V1 over T1 equals V2 over T2. Plug in the pieces that we know. We know our initial volume and our starting temperature. We know our second volume is 2.69, and we are not sure of our second temperature. So here we have some algebra to do, and so I like to do the cross multiplying method. So we'll take 4.98 times T2 will equal whatever 2.69 times 20.5 is, and that we would get 55.145. And so now to solve for T2, we divide each side by 4.98. Oops, sorry, 98. And we get our second, or our final temperature as 11.07 degrees Celsius. So again, the rest of these Charles Laws problems, I believe they go up to number 8. Same process, but different variables you might be solving for. The last set of problems would be Amitern's law. And so again, start by writing your variables along the left-hand side. This one deals with pressure and temperature. So the gases in a hairspray can are at a temperature of 28.3 degrees Celsius and a pressure of 29.87 pounds per inches squared. If the gases in the can reach a pressure of 92 pounds per inches squared, the can will explode. To what temperature must the gases be raised in order for the can to explode? So we're starting with a temperature of 28.3 degrees Celsius and a pressure of 29.87 pounds per inches squared. And our second pressure is at 92 pounds per inches squared. And we're trying to solve for our second temperature. So again, set up your formula. P1 over T1 equals P2 over T2. And then plug in your known variables. And so we have 29.87 for our first pressure. Our first temperature is 28.3. We know our second pressure is 92, and we're solving for our second temperature. Again, here's a time where we can do our cross multiplying. So our initial will be 29.87 times T2 equals 92 times 28.3. That gets us 29.87 times T2. Multiply that right-hand side out, and you should get 2,603.6. And then our last step to solve for T2 is divide each side by 29.87. And so in order for the can to explode, the temperature must reach 87.164 degrees Celsius. And so the rest of the worksheet works about the same. One thing to note is that for your pressure units, they will change. You could see that millimeters of mercury. You could see PSI, pounds per inches squared. All are indicating units of pressure. When you write your final answers, make sure that you always have a unit with your number. The unit is worth half a point, as well as the number is worth that second half a point. So if you don't have a unit on your final answer, you will lose half a point.